in this example, the instructions are to, what are they? They're to use a graph to find the zeros of the function. I think, just based on the types of problems that are in the book, they mean to use like a graphing calculator. So this is a good time to practice using that and finding zeros. So I'll show you that. Hopefully I showed you that in class, if you needed to remember. But I don't have a graphing calculator with me right now, so I'm going to try and do it on just on my own. I'm going to plot stuff. So first, you could like shift it around if you remember the rules for shifting. I feel like a lot of people don't, but I'm going to rewrite this just in case. Plus 3, like that. I'm going to rewrite it like that. And then I want to point out that the way this is written, it's kind of hard to understand, but when something is written like this is the same thing as negative and then quantity 2 raised to the x. This exponent here has no effect on that negative. It doesn't even know it's there. The only way it would have an effect on that negative is if it had parentheses like that, but it doesn't. So it means this. That's something super, super important to remember, because lots and lots of people mess up just for that little negative. So something like that you should remember. So this is our function, and I'm just going to start plugging stuff in. I know that normal exponential functions look like that, but this is all changed around. So let's see what happens. I'm supposed to find the zeros using a graph. So I'm going to graph it first and then look at where the zeros are. You can use a graphing calculator for this, but it's also good to practice graphing by hand as well. So I'll plug in 0. If I plug in 0, I get, what do I get there? 1, which turns to negative 1, plus 3, which is 2. So plug in 0 and I get 2. And then plug in 1 and I get negative 2 plus 3. That's 1. So plug in 1 and I get 1. Plug in 2 and I get 2 squared is 4, negative 4 plus 3, that's negative 1. So it's just going down, down, down. Something like that. Alright, cool. Let's go the other way. It's probably going to go like this then. Yeah? Yeah. So let's see. Plug in a negative 1. Negative 1. If I had a negative 1 there, what would that be? 1/2, right? It would change to a 1/2. And then it's still negative. Plus 3. So that's 2.5. Positive 2.5. So that's 2. And then that's 3. 2.5 is right there. I bet there's an asymptote maybe somewhere there. Maybe at 3. Let's check it out. Let's see. I bet it is. I bet it is. Plug in negative 2, and what do I get? Negative 2, that would be 1 over 2 squared, which is 4. And it would be negative 1/4 plus 3, so that's 2.75. Yeah, there's the asymptote. 2.75 is getting a little bit closer, but not touching. So there is an asymptote there. And this is what it looks like. So, since I don't have my calculator to do this, I'm just going to estimate that it's around 1.5-ish. And then you could get the exact answer in your calculator. I don't know, I can only show you how to do that in class, so hopefully I did. But there you go. That's how you graph, just plotting points. The main idea, the main thing, is realizing that this means the same thing as this. That's most important. If you want it to affect this negative, you have to have parentheses around the base and that negative. So there you go. That's it for that one. The 0 is where it crosses the x-axis. Normally, we can, if you want to find the zeros of a function, which are the x-intercepts, you make y 0. So let's try and solve algebraically for that 0. Let's see what happens. So that would get. This is not part of the problem. You're not required to do this, but I want to see. So then we have this plus 3. I'm gonna subtract or add the 2 raised to the x over to the other side. So then I get this, and if I want to get the exponent down, then I can take the natural log of both sides. ln. This is important to remember. And then I can take this and move it out in front. So I have to sneeze. I have to sneeze. I paused it and I sneezed. Sneezing feels good. Okay. So x ln of 2. ln of 2 is just a number. Natural log of 2 is just a number. Natural log of 3 is just a number as well. So if I want to solve for x, I divide by the natural log of 2. So x equals ln of 3 divided by ln of 2. What is that? I can plug that into my normal calculator. I don't have a graphing calculator, but I have a normal one. And that is, I'm going to do to 3 decimal places, 1.5, it's approximately 1.585. So I was close. I had a good estimate. All right, that's important, I think, to have that anyway. So it's good to review that. All right, I'm done with this.